Okay, so this is AS1 Physics 1 January 2009 and it is question 6. And we start off with something which has come up lots and lots of times in recent years, so you need to be prepared to answer the difference between resistance, resistivity, and in the first one here we'll just write down the equation relating R to rho. So R, the resistance, is equal to rho times L over A, where L is the length of the conductor and that would be in meters, and A is the cross-sectional area in meters squared. Then an aluminium wire is 1.5 meters long and has a radius of 0.56 millimeters. When the current in the wire is 0.32 amps, the PD between the ends of the wire is that. Calculate the resistivity of aluminium. So we're trying to work out the resistivity, so we know that the resistivity is going to be the resistance times the area divided by the length, but we need to work out the resistance first of all, because we know R is equal to V divided by I, so that's equal to 0.013 divided by 0.32 amps. So that gives us the resistance, which is equal to, whenever we calculate, that's 4.06 times 10 to the minus 2 ohms. Right, so we've got a resistance of 4.06 times 10 to the minus 2 ohms, and we're going to use that in this equation over here to work out. So first of all, we've got a diameter, now we've got a radius, so the area is equal to pi r squared, so the resistivity now is going to be equal to the 4.06 times 10 to the minus 2, that's the resistance, times the area, so it's 0.56 millimeters. Okay, so just be careful there with the millimeters. So it's pi r squared, so that's 0.56 times 10 to the minus 3 all squared, pi r squared for the area, divided by the length, which is 1.5 meters long. So the resistivity then has to be equal to, put that all into your calculator and work that out. That gives us 2.7 times 10 to the minus 8 ohm meters. It's for a metal, it's for aluminium, so something times 10 to the minus 8 is a good kind of value to have. So 2.7 times 10 to the minus 8 ohm meters, we'd be happy with that. Final part of the question then goes on to say that the aluminium wire A is replaced with a different aluminium wire of length 1.5, the same length, but of radius half the previous state. How the resistance and the resistivity of the wire B compare with the values of this. Now, first of all, if we consider the resistance, well, the resistance will have changed. How will it have changed? Well, the resistance will, we've got a radius which is half of the previous value. Right? So if we just remember what our equation is, R is equal to rho times L over A. So we've made the cross-sectional area here. Okay? So we've made the cross-sectional area much smaller. How much smaller? Well, we've halved the radius, but remember the area is equal to pi r squared. So if the radius goes down by 2, the area will go down by 4. Right? So that means that the resistance of wire B will be 4 times A. Right, so the resistance will be 4 times bigger than that of A. And why is that? Well, that's because the resistance is proportional to 1 over the area, and the area is proportional to the square of the radius. So if you change that by half the previous, then it's going to be 4 times whenever it comes through to the resistance. The resistivity of that, well, the resistivity stays the same. Why? Well, because resistivity is a property of the material. I'm using the same. A and B are both aluminium. So we have the same material, therefore we will have the same resistivity.